Section B, Modules. Module 1, Matrices. Question 1. A school canteen sells pies, rolls, and sandwiches. The number of each item sold over 3 school weeks is shown in matrix M. Part A. In total, how many sandwiches were sold in these 3 weeks? For this, we are going to look at the elements in column 3. That is 60 plus 43 plus 56, which is equal to 159. This question is worth 1 mark for the correct answer. The element in row I and column J of matrix M is Mij. Part B. What does the element M12 indicate? Element M12 is in row 1 and column 2. This element is 24. So M12 indicates that 24 rolls were sold in week 1. This question is worth 1 mark for the correct answer. Part C. Consider the matrix equation given where A is the cost of 1 pie, B is the cost of 1 roll, and C is the cost of 1 sandwich. Part I. What is the cost of 1 sandwich? Using available CAS technology, we are going to use TI Inspire. We add calculator, and from the menu, we choose algebra, and then solve. And then we write this matrix equation, and we solve for A, B, and C. So the cost of 1 sandwich is $3.80. This question is worth 1 mark for the correct answer. Part 2I. The matrix equation below shows that the total value of all rolls and sandwiches sold in these 3 weeks is $915.60. Matrix L in this equation is of order 1 by 3. Write down matrix L. Matrix L, 1 by 3, which means 1 row, 3 columns. We only need the last 2 elements of the column matrix. 428 plus 487.60 equals 915.60. We are going to write matrix L as matrix X, Y, Z. We multiply the 2 matrices on the left-hand side of the equation as shown. We don't need 491.55, so we multiply this one by 0, and then we multiply the other 2 quantities by 1. So matrix L is going to be equal to 0, 1, and 1. This question is worth 1 mark for the correct matrix. Question 2. Junior students at this school must choose 1 elective activity in each of the 4 terms in 2018. Students can choose from the areas of performance, sport, and technology. The transition diagram below shows the way in which junior students are expected to change their choice of elective activity from term to term. Part A. Of the junior students who choose performance in 1 term, what percentage are expected to choose sport the next term? In the transition diagram, we start from P and we follow the arrow towards S. Above this arrow, we have the answer 40%. This question is worth 1 mark for the correct answer. Matrix J1 lists the number of junior students who will be in each elective activity in term 1. Part B. 306 junior students are expected to choose sport in term 2. Complete the calculation below to show this. First, there are 300 students in Term 1 in performance. We know that 40% of these are going to choose sport in Term 2. So we multiply 300 by 0.40. 240 students choose sport in Term 1. From the transition diagram, we notice that 60% of these students are expected to choose sport in Term 2. So we multiply this number by 0.60. 210 students choose technology in Term 1. In the transition diagram, we follow the arrow from T to S, and we notice that this is 20%. So 20% of these students are expected to choose sport in Term 2. So we multiply this number, 210, by 0.20. This question is worth 1 mark for the correct answer. Part C. In Term 4, how many junior students in total are expected to participate in performance or sport or technology? The total number of students does not change. So we have 300 plus 240 plus 210, which is 750. This question is worth 1 mark for the correct answer. Question 3. Senior students at this school will also choose one elective activity in each of the 4 terms in 2018. Their choices are communication, investigation, problem solving, and service. The transition matrix T shows the way in which senior students are expected to change their choice of elective activity from term to term. Let Sn be the state matrix for the number of senior students expected to choose each elective activity in term n. For the given matrix S1, a matrix rule that can be used to predict the number of senior students in each elective activity in terms 2, 3, and 4 is given below. Part A. How many senior students will not change their elective activity from term 1 to term 2? For this, we are going to look at the elements on the leading diagonal. They show no change. So we multiply 300 by 0.4, 200 by 0.4, 200 by 0.3, and lastly 300 by 0.2. And this gives us a total of 320. So this question is worth 1 mark for the correct answer. Part B. Complete S2, the state matrix for term 2 below. We know that S2 is equal to TS1. We multiply these two matrices and we end up with the column matrix S2. This question is worth 1 mark for the correct answer. Part C. Of the senior students expected to choose investigation in term 3, what percentage choose service in term 2? From S2, there are 200 senior students choosing service in term 2. Now let's calculate S3, which is T times S2. From S3, there are 240 senior students expected to choose investigation in term 3. In the transition matrix, we are going to look at the percentage of senior students that are expected to choose investigation in term 3 from the students who chose service in term 2. And that is 0.3 or 30%. So 30% of 200 is equal to 60. Now 60 out of 240 is 25%. This question is worth 2 marks. 1 mark is going to be for the final answer, for the final correct answer, and 1 mark is going to be for one additional step. From the 2017 VC examination report, this question was not answered well. Some students were able to find either the 240 doing investigation or the 60 transitioning from service to investigation, but were unable to link these together. Part D. What is the maximum number of senior students expected in investigation at any time during 2018? From matrix S1, in term 1, there are 200 students. From S2, in term 2, there are 250 students. From S3, in term 3, there are 240 students. And now we need to calculate S4, which is equal to TS3. From S4, the number of students in term 4 is 239. So the maximum number of senior students expected in investigation at any time during 2018 is 250. This question is worth 1 mark for the correct answer. From the 2017 VC examination report, 239 was the most common incorrect response from the steady-state matrix.